Phil, and you're watching The Joy of Electronics. In this video, I'm going to go over this Peavey Rage 158 that I got that was having some issues and that I managed to diagnose and fix. So I thought I'd talk about what that entailed and some things with these amps that are common. So I've got it open here. It's pretty easy to take it out. It's got 3 screws that go into the chassis from below into the top of the chassis, and then it's got 2 bolts that come down through the handle and into these plastic cylinders, mounts, and through the chassis. Now, this method of the handle mounting through the chassis, it holds the chassis in place, but that's what causes a lot of the problems with these amps, because you have these massive screws that go through here, and if you tighten them too much, they're going to pull up on this part of the chassis here, or every time you actually lift the amp by its handle, it's going to pull up on these 2 points of the chassis. Now that ends up bending the chassis, and because the circuit board is mounted to the chassis and the inputs and outputs are all mounted to the chassis, that puts a lot of stress on the circuit board, and a lot of things happen because of that. The traces crack, the solder cracks, and the joints fail basically, and that's some of what happened to this amp. But we'll get into that. So let me take the board off, and I'll show you how it mounts. So we've got a screw here. Let me just unplug it first because I was doing some tests. Screw here, 3 screws here, and a screw here. The first thing after I took the board off that I noticed was that there was a bad solder joint, a very obvious one, and so I had to take care of that. But after that, some other issues persisted. So this is an IC based amp with this TDA 2040. There's a couple different versions of the Rage. This one is the trans tube, and I'll post a link to the schematic in the description. You want to get schematics for amps if you're working on them. It's to ensure that you're doing things properly and looking at the right components. So one of the things to note is when I originally got this amp, it was from a neighbor down the street, said it was kind of flaky. Sometimes it would work, sometimes it wouldn't. Headphone out would work sometimes, the normal output would work sometimes, and then when I opened it up the first, and before I took this off, what you see here around the IC is a silicone pad. Now when I got this amp, there was the residue of thermal grease or heat compound or thermal compound that was between this IC and the heatsink, and between the heatsink and the chassis. Now that comes into play later. But for now, the first thing I did was pop the circuit board off and turned it over. So to do that, you have to take the nuts off of the 1/4 inch jacks, as well as you have to take the knobs off. This one has this type. And then the circuit board doesn't come completely out because this power switch is hardwired and it comes out the front. So that would have to be desoldered to actually, I believe it comes out the front. It would have to be desoldered to actually come off the board. So the silicone pad is kind of sticking a bit, but that's fine. So we'll take this out, and I'll show you how the board mounts. There's also a speaker output, feeds through the chassis here. I put this grommet in. This was just bare before I put that rubber grommet in to prevent chafing of the wires against the board. So thankfully you can take this out and I'm going to lever it to the side, but you can see that the board mounts to the chassis through two of these, one here and one on the other side, and then it mounts, the IC mounts to the heatsink, and the heatsink mounts to the chassis through the board as well. So those are the mount points, but you can see as I pull up on this, it's not very heavy gauge sheet metal, so the whole thing bends, and then when it does, the board bends. Now, let's see if I can maneuver this around. Looks like I'm going to have to move it. I do have a little speaker attached, just a little test speaker. Well, it's not attached anymore, so we'll just detach that so I can shift this over and you can see the board. So there's the board. I believe it was this resistor up in the corner that I initially noticed was the solder had dried out and it was kind of loose, so I reflowed a lot of that. That type of having to reflow joints is a common theme with this amp because of the way that the board flexes. So there was another joint in the end that needed reflowing as well, but I'll get to that. So let's put this back and we'll continue. So once I reflowed that initial solder joint that was obviously, you know, it looked like there was maybe a bit of damage there. So I fixed that up, but the amp was still not working. Well, let me clarify. It seemed to work until I put the board back in place. There we go. It's just this power indicator LED kind of gets bent back a bit, so push that in there. Alright, so what would happen was everything would work fine. I thought I was golden, put the board back in place, and then things would stop working. Now, when I had taken the board off, I kind of cleaned up the thermal compound that was under the IC and under the heatsink, just to clean things up so I could start fresh. Now what I realized was that when I put the board back in place, the heatsink would make direct contact with the chassis, and the IC would make direct contact with the heatsink. Now, I didn't at first realize that that might be a problem, but after chatting with some folks and doing more investigation, I realized that if this IC didn't touch the heatsink, or the heatsink didn't touch the chassis, basically if we didn't ground the heatsink to the chassis, then everything worked fine. And so I started to wonder if that thermal grease or thermal paste was important in the circuit. And if I look at the schematic here, there's actually two grounds. There's an A ground 1 with a circle around it, and then there's an A ground with no circle around it. So this tells me that we've actually got two grounds. And when I continued to look at the schematic, I found that the input actually grounded to the chassis, whereas it didn't seem like the IC was supposed to ground to the chassis directly, at least, which is kind of odd because it's got screws that go through to the heatsink, which would short it to some degree, and it's got screws that go through the board, through the heatsink to the chassis, which would ground it to some degree. Now, it turned out it wasn't just the IC touching the chassis, it also had to be the input, or one of these jacks touching the chassis, because they actually have, I just put this in, I'm going to take it out again. I don't know if you can see this, but there's a plate on the front of each of these, well, at least these two jacks, the two inputs, and that grounds those jacks to the chassis. Now, I realized that when those jacks were grounded to the chassis and the IC was grounded to the chassis through the heatsink, the amp wouldn't work. So I decided to try to isolate the IC from the chassis again, using these two little thermal pads, or two little silicone pads that I had gotten for another purpose, had laying around from a larger piece, so I just chopped them off and put them down. Now this is after a lot of swapping out components, taking them out, checking them, checking the diodes, checking the electrolytics. Everything seemed fine. So I put in the silicone pads, and things seem better, but not perfect. There was still some flakiness. I was able to mount the board, but there was still some flakiness. This time I got the whole thing back into the amp, but as soon as there was any pressure on these two mount points for the handle bolts, things would flake out. And I thought, okay, now we're back to the original problem of the board is flexing to some degree and something's shorting out because of that. So at that point, I switched to the handy chopstick and started turning it on, poked around. It's non-conductive, so you can tap things, you can see what's going on everywhere. And so I can do that now, although this power LED is bent again. Hopefully that's not going to snap through all these, but that's an easy fix if that happens. So I've got it hooked up to this little speaker, so I'll turn it on and we should get some volume. Ah, I didn't plug it back in, so let me turn that off again. I'll plug it back in, turn it on, volume down. There. So we got the speaker on, we've got everything. This is isolated. The input and CD input are both grounded to the chassis, so everything's working. So what I did at this point was I kind of poked around. You know, something's popping a bit, a little crackly. I found that when I lifted the board here, you know, I tried to simulate what would happen when the chassis flex, so I'd push down on the board, pull up on the board a bit, and I found that, well, I didn't find that. That's something new, but I'm not surprised since I'm moving it so much here. I'll just hold it over here. I haven't put the bolts back in, which you, or screws, which you would do. I found that when I bent the board here, or when I had kind of abused it a bit here, I'd get a lot of popping, a lot of snapping in and out. So then I kind of tapped around the components here, which is what you do. That's what the chopstick's for. Some good tapping. And I found C23 here was really loud. Really loud popping when I hit C23. So I thought, and you know, when I moved the board here. So I thought, great. I flipped the board over. I reflowed this joint here where C23 meets pin 5 of the IC. And that was the last thing. That was it. After that, I mounted everything back up, and the amp worked fine, worked great, all put together, all assembled with stresses in all the same spots. So in short, the problems that I experienced with this amp that I solved that ended up fixing the amp were: one, there's a cold solder joint here, so that needed redoing. There was the thermal grease is somewhat required on this amp. That changes the resistance between this IC and the chassis, which is seems to be a requirement for this amp to function properly. I believe it's to do with the bias of the preamp is related to that second ground. So there had to be something there. So the silicone pad takes care of that. And then the third issue was another cold solder joint between C23 and the main IC. So that got this amp going. The other thing that I did to kind of prevent any as much future stress as I could through these mount bolts was I 3D printed a couple of these cylinders. Now they sit right over top of these mount bolts, and you know, to my mind, that's going to help isolate the stress of these mount bolts to that portion of the chassis, because these cylinders will press against the top of the cabinet as well as the chassis, and therefore kind of counteract the upward stress caused by the handle mount bolts. So we'll see how that works out. You know, maybe you have to do that, maybe you don't. You know, some metal ones might work if you don't have a 3D printer, or not at all. I really don't know if that's going to have much effect at all. So that's it. That was my experience fixing this Peavey Rage 158. Now, a couple other things that I've read happen and aren't surprising that they happen with this amp are these input jacks. You know, because they are mounted to the board, and this is true for all input jacks mounted to boards usually, that puts a lot of stress on the solder joints of the inputs. or outputs, because you're putting in, you know, 1/4 inch jacks and you're wiggling them around, and because this is mounted to the board, you're wiggling the board. These break their solder joints really commonly, so that's something to check. Reflow all these or replace them either with off-board jacks or just replacements of these. So that's something to check on these amps. Make sure all the jacks are soldered correctly and are conducting in all the proper ways. Another thing that can happen is these jacks, at least the CD input jack, has a switch on it, so that when something's plugged in, it's going to disconnect from the headphone jack. When you plug in headphones, it's going to disconnect the speaker. So if these get too worn out, they're not going to have the pressure that they need to maintain a connection when there's no headphones plugged in. So that's another thing to check, that you know, and you can check that just by you know, if you're not getting a signal, you can press down to actually make this connection by force, and if the signal comes back, then you know that this isn't resting properly on you know, where it should, and so that when headphones aren't even plugged in, you're not getting a signal out of the speakers, because the amp you know, it thinks headphones are plugged in, so it's cutting off the signal. So those are some common things to check with this amp. I can't think of anything else at the moment, so how about we wrap that up? This has been The Joy of Electronics. Thanks, and we'll see you next time.